Our next exponent rule is called power of a power. It's when you're raising something that already has an exponent to another exponent. You're just going to multiply the inside exponent with the outside exponent. So a to the m, all of that raised to the nth power would be a to the m times n power. So x to the 5th raised to the 3rd power is going to be x to the 15th. And the reason why, because, well, 5 times 3 is 15, but the reason why is what you're doing is you're taking x to the 5th and you're cubing it. You're taking x to the 5th and multiplying it by itself 3 times because we're cubing it, raising it to the 3rd power. So what we learned earlier was when you multiply things that have the same base, you add all the exponents. And 5 plus 5 plus 5 is 15. So this is x to the 15th. A negative exponent is weird, but you can raise a base to a negative exponent. And just like we're not allowed to leave like radicals in the denominator of a fraction, like that's just, you're just not allowed to leave it like that. It's not a fully simplified answer. A similar concept is you cannot leave a negative exponent in your final answer. It's not fully simplified and you'll lose points, and it's just not done. So the way that you get rid of a negative exponent is you're going to send the whole thing, the base and the exponent, to the numerator. If it starts in the denominator, you're going to send it up to the numerator. If it starts in the numerator, you're going to send it down to the denominator. So basically, to get rid of a negative exponent, you're just sending it across the fraction bar. So a to the negative n power is going to become 1 over a to the n. You have to just send it to the denominator. 1 over a to the negative n. The a to the negative n started in the denominator, so you're going to bring it up, and it's going to join that 1 in the numerator. Okay, so let's look at example 5. Y to the negative 3rd power. To get rid of my negative exponent, I'm going to send y to the 3rd to the denominator, and it becomes positive. When you move it across the fraction bar, the exponent becomes positive. Well, then you're thinking, well, what's left behind in that numerator? There was a 1 in front of the y to the negative 3, so there's a 1 holding down the fort in the numerator. So now it's 1 over y cubed. Okay, a cubed over b to the negative 2 power. So I need to get rid of this negative exponent, so b squared, I need to move it to the numerator, from the denominator to the numerator, but there was already an a to the 3rd power in the numerator, so the b squared is just going to come up and join the a to the 3rd. So now there's just a 1 in our denominator. There's like nothing left over besides a 1 in the denominator, so I don't need to write that. This is weird, but when you raise something to the 0 power, so when your exponent is 0, it doesn't matter what it is. It could be just a single variable. It could be something really complicated in parentheses, like whatever. If you're raising something to the 0 power, it always is equal to 1. Doesn't matter. So x to the 0 power to the 0 exponent is just 1. On this one, I am raising all of this stuff inside of the parentheses. 2ab to the 7th. All of that is getting raised to the 0 exponent. So even though it's really complicated and crazy, this is just 1. I can't lose the 4, so this is 4 times 1. So the final answer is 4, but all of this stuff that's getting raised to the 0 exponent is just going to turn into 1.